All right, so if you look at the top of Wednesday's page in our packet, you'll see that our first activity was the Kahoot Learning Activity A. We just did that. That was a bit of a review of some of the concepts we've been dealing with this week regarding roots, and you guys did excellent on that. I feel like this class has a really good understanding of what roots are, how we find them. You guys did great. We're going to talk about something related, but it's going to feel a little new at first today. But by the end of today's class, you will realize how truly easy this is, okay? So be prepared to feel a little confused for a while, but by the end of class, you guys are going to be pros at this, I promise. We have a definition, a new definition here of something called factored quadratics. Sometimes quadratic functions are written in the form of two factors being multiplied together. What are factors? Factors are two things that are being multiplied. Think about this, for instance. What would I do if I wanted to take the number 6 and factor it? How would I write it? Can I get a volunteer to tell me how you would write 6 if you factored it? Kendall? 3 times 2. So if you wanted to rewrite 6 in factored form, you would write it as 3 times 2. Two things multiplied together. That's what factors are. So if we have a quadratic that is factored, it might look something like this. Y equals x plus 3 times x minus 4. This is a quadratic that is written in the form of two things being multiplied together. So the first part of the multiplication is our first factor. We'll call this factor 1. And then the second piece of the multiplication is our second factor, factor 2. This is made up of two factors. Does everybody see that? It's a pretty basic concept, but we're just learning some new terminology here. How do I even know that this is a quadratic? We made a big deal about this last week. Quadratics always have an x squared in them. But do you see an x squared in this? No. So how do we know this is a quadratic? Well, one of the things we just mentioned is that these two factors are multiplied together, x plus 3 times x minus 4. These two things are being multiplied. What would happen if I multiplied this out? We multiply our first times our first times our second times our first, and our second times our second. This is a process called FOIL. We do our first times first, our outside, our inside, and our last times last. FOIL, first, outside, inside, last. When you multiply all of this out, you get x squared minus 4x plus 3x minus 12. This is the FOIL process. And then we have a couple of like terms here. And Rebecca, you were sort of hinting at this. When you have like terms, you can combine them. So we can combine this into x squared minus x minus 12. We will go over how to do this in detail when we get back from break. For now, what I want you to see is that y equals x plus 3 times x minus 4 is the same as, it's the exact same thing as y equals x squared minus x minus 12. These two things are exactly the same. All we do is we multiply out the factors. And we do that by using a process called FOIL that we are going to learn in the future. So what I mean by y, the top y equals and the bottom y equals, these are the exact same thing. What I mean by that is, imagine if you had y equals 2 times 3 and y equals 6. These are the exact same thing because 2 times 3 is 6. So that x plus 3 times x minus 4 is the same exact thing as x squared minus x minus 12, okay? And we'll talk about how we can do these for ourselves when we meet again after break. So I just wanted to show you that this is a quadratic equation, this x plus 3 times x minus 4. For some reason, my line got kind of messed up. There should be a line here that you're writing the x squared minus x minus 12 on that line. Okay, so now that we've gotten the multiplication out of the way, I hope you're convinced, maybe you don't understand why, but I hope you're convinced that the factored form of the quadratic and the standard form of the quadratic, those are just two different ways to write the same equation. So now we're going to talk about why we care. There's this line in bold here that says it is very easy to find the roots of a factored quadratic. It is very easy to find the roots of a factored quadratic. And I'm going to explain why. So a factored quadratic, you're going to want this in your notes. A factored quadratic looks like this. X plus 3 times, hold on, let me make some more space here. We're going to do y equals x plus 3 times x minus 4. This is just the example of the factored quadratic that we're using. When we want to find roots, so to find roots, we have to put 0 in for y. That's how we find roots, is we let our y value be 0. So I'm actually going to put a 0 in right here in place of the y value. I'm just going to cover my y up with this really big 0. So we have 0 equals x plus 3 times x minus 4. Now I need you guys to think about this for a minute. I have two things being multiplied together, x plus 3 times x minus 4. We don't need to think about these as x's and 3's and 4's right now. Let's just think about them as two things being multiplied together. So don't write this down, but I'm going to say, so we have like something being multiplied to something else, and it's equal to 0. It's equal to 0. What do we know about these blanks, these two things that are being multiplied together? What's the only way that they could possibly be equal to 0? Any thoughts? One of those things has to be 0. The only way to get 0 as the answer to a multiplication is if one of these things, either the first one or the second one, has to be 0. One of them has to be 0. Does that make sense? That's the only way you can get 0 as a product of two things being multiplied. So what that tells us, let's go back to taking our notes, so you will want to write this down. The fact that these two things are multiplied together and equal 0 means that one of them has to be 0. So what we can do is we can say, okay, well, what if it's the first one? What if it's x plus 3 that's equal to 0? What would x have to be equal to for this to be 0? We just have to solve for x. So you're going to subtract 3 from both sides. And for this first factor, we would need x to be negative 3. Does that make sense? Or it could be our second factor that's equal to 0. So we would write this one as x minus 4 is equal to 0. For this to be true, what would x have to be? Well, to get x by itself on one side, we would add 4 to both sides, and you'd end up with x equals positive 4. These two answers right here, these are our roots. You get two roots, x equals negative 3 and x equals 4. And we have all of these calculator skills that we can use to verify this. If you want to, you can pull your calculator out. You can go to the y equals part of your calculator, and you can type in parentheses x plus 3 parentheses, and then another set of parentheses, parentheses x minus 4 parentheses. So it just will look exactly the same way it looks on our page, and then you can graph it, and you can look at the or the x-intercepts. Those are your roots. So we already know how to do problems like these using a calculator, but now we know how to do them by hand too. So we're going to do 4 examples, and you're going to start to notice a pattern, I hope. In example 1, we just did this example, but I want to show you just really quickly again what the steps are. If we want to find the roots, we have to put 0 in for y. If these two factors are multiplied together to equal 0, that means that one of these has to be 0. So maybe it's x plus 3 that equals 0, or maybe it's x minus 4 that equals 0. We're going to get a different answer from each of these choices, right? So for the first one, we subtract 3 from both sides, which will give us x equals negative 3. And for the second one, we can add 4 to both sides, which would give us x equals positive 4. So we end up with 2 answers, negative 3 and positive 4. Those are our roots. We already did this example. I just wanted to write it out one more time so that it was very clear what the steps are. Let's look at example 2. In example 2, we have a different problem this time. We want to know what are the zeros of this factored quadratic. Now, zeros, that means the same thing as roots. So all we're going to do is we're going to put a 0 in for y, which means we can use this trick. One of these factors has to be 0. So we're going to let x minus 2 equal 0, and we're going to let x minus 10 equal 0, and we're going to solve both of these. So for my first factor, if x minus 2 equals 0, that means x equals positive 2. And for my second factor, if x minus 10 equals 0, then that means x equals positive 10. So we get 2 roots, positive 2, and positive 10. Is anybody starting to see a pattern here? Notice in example 1 what we started out with and what we ended up with. We started out with a plus 3 and a minus 4. We ended up with a minus 3 and a plus 4. In example 2, we started out with a negative 2 and a negative 10. We ended up with a positive 2 and a positive 10. And that's because of this part. To get rid of a negative 2, you have to add 2 to both sides. So it's going to become positive when you move it over to the other side. So this is a pattern that I hope you'll come to recognize. This will help us answer questions like this really fast. We'll be able to do it really fast. Okay, so for example 3, same question. What are the solutions, or what are the roots of this factored quadratic? So we have to put 0 in for y, which means that one of these two things has to be 0. So I'm going to split these up into 2 separate. Maybe it's the first factor that's equal to 0, or maybe it's the second factor that's equal to 0. Now we have to solve each of these for x. But with our first factor, we have x equals 0. That's already solved. We don't have to solve that anymore, so that one's good. We really just have to solve the second factor. So we'll subtract 5 from both sides, and we get our 2 answers, x equals 0 and x equals negative 5. One more example, example 4, is quite a bit more challenging than the other examples we've done so far. In example 4, we have the same type of problem. What are the roots, what are the x-intercepts of y equals 3x minus 2 times 2x plus 7? Since we're trying to find the roots, we put 0 in for y. And then we know that one of these two factors has to be 0. So if it's the first factor, then we'd have 3x minus 2 would be equal to 0. Or if it's the second factor, then we'd have 2x plus 7 equal to 0. We have to solve both of these for x. This one's going to require a few more steps than the other examples, though. First, we have to add 2 to both sides. So we get 3x equals 2. But we're not done. We still haven't completely solved for x. So what do we have to do next? Anybody want to help me here? Divide both sides by 3. And that's going to get that x completely by itself. So we'll divide by 3, divide by 3. And that's going to give me x equals 2/3, which is a fraction, obviously. That's okay. Our answers can be fractions. They can be decimal numbers, all kinds of things. They can be positives, they can be negatives. We end up with positive 2/3 as the x value for this factor. Let's do the same thing for the other factor. Our other factor, to get x by itself, we're going to have to subtract 7 from both sides. And then to get that x completely alone, we need to divide both sides by 2. And that'll give us, as our x value, that'll give us a negative 7/2. So our two roots are 2/3 and negative 7/2. So there's a pattern here as well, where in our first factor, I'm going to do this in blue, but then I'm going to erase everything. In our first factor, where we did have a negative 2, we now have a positive 2 over 3. So it was kind of like positive 2 over 3 is sort of where we got our answer from. And then for the next one, we ended up with a negative 7 over 2. So there's a bit of a pattern with these, and being able to recognize that pattern will make you faster at identifying your roots. So what we're going to do with the rest of our class time here is another Kahoot activity, and we're going to practice identifying roots as fast as we can.